4. So problem 4, use appropriate techniques to solve the following limits. So when you deal with limits, what's the first thing you always try? You try to sub in, right? Usually when you do substitution, you get the answer, then you don't need any techniques. For example, here, but when you try subbing, the top is 1 minus 1, it's 0, right? The bottom, 1 squared minus 1 is 0. So when you try subbing, it gives you 0 over 0. Then you cannot make any conclusion from substitution. Okay, and because here it's a 0 over 0 case. Okay, later we're going to use L'Hopital's rule, but now if it's 0 over 0, usually it's because both the top and the bottom has a common factor. Okay, so you can factorize both sides. For example, bottom, x squared minus 1, it's x minus 1, x plus 1. Right, top, x cubed minus 1, it's x minus 1, x squared plus x plus 1. Okay. Now the next step, you can cancel these two out. Why? Because here it's a limit. The concept of the limit is x is approaching 1. Okay, x is never exactly at 1. So when x is not exactly at 1, then x minus 1, they are some non-zero value. Right? Any two non-zero value, if they are the same, they can be canceled out. Okay. So here is just the top is x squared plus x plus 1. The bottom is x plus 1. Okay. Now you do the substitution. Here is 1 squared plus 1 plus 1. Okay. Now you can get the answer easily. Right? It's not substitution, it's 3 over 2. Okay. Okay. Part B, very, very similar. Again, always try substitution. All right. If you try substitution, bottom is square root of 2 minus square root of 2. It is 0. Right. The top, square root of 2 square minus 2, it's also 0. So try substitution, it's right 0 over 0. So again, it should be a common factor. And here it's right. Again, x squared minus 2. It can be rewritten as x plus 2 times x minus 2. Okay, over the bottom, it's x minus 2. X minus square root of 2. Okay, again, same logic, because x is never exactly square root of 2, so top and bottom, they can be canceled out. So what's left is this x plus square root of 2, and it is just 2 square root of 2. Okay, eliminating common factors. So part C, limit x is approaching 0 from the left-hand side. Okay, last week we talked about if x is approaching 0 from the left-hand side, that means what? That means x is approaching 0. Right, means x is approaching 0 and x is always slightly smaller than 0. Okay. If x is approaching 0 from the right-hand side, that means x is approaching 0, but x is always slightly greater than 0. Okay. Then, now it's x over square root of x plus 1 minus 1. Okay, again, do substitution. If it's 0, the bottom is just 1 minus 1. It's 0, right? Top is 0. So again, you should expect a common factor. Okay, but here, it's hard. It's hard to factorize the top or factorize the bottom, okay, and quickly find a common factor. So instead, we use another way to find a common factor. We use rationalization, okay? Because the bottom, it's the square root minus something, right? So we can multiply a square root plus something to the bottom. Okay, then it will rationalize the bottom. Okay, so in the bottom it's square root minus 1. So we multiply square root plus 1. Okay, and on the top we do the same thing. Square root plus 1. Okay. And then here it's a minus b, right, times a plus b. So it's a squared minus b squared. So it's square root of x plus 1 squared, which is x plus 1 minus 1 squared. Right? The top is x times square root plus 1. Okay. So now you can see the bottom, right? These two parts cancel out. So the bottom is just x. The top here has another x. Right? So these two, they can be canceled out. Okay. So it's just square root of x plus 1 plus 1. Okay, and now just do substitution. The result is 2. Okay. Do you have any questions for this part? No. Yes. Okay, part D, very similar. Right. Limit t approaching negative 3. Right, t squared minus 9 over 2t squared plus 7t plus 3. Okay, again, do the substitution. If it's negative 3 squared, the top is 0. And then you do the bottom, you do the substitution, right? Minus 7t, right? You know, plus 7 times negative 3. Just do the substitution, you find that it's still 0 over 0. Okay, so again, you expect a common factor. And how to find this common factor? The top, right, t squared minus 9, it's t plus 3 times t minus 3. And here, the bottom, right, quadratic function, just to need to find, just need to factorize it. So it's 2, 1, 3, 1. Okay, so it's 2t plus 1 times t plus 3. Okay, again, these two parts cancel out. Right, these two parts cancel out. So we have t minus 3 over 2t plus 1. Okay. Then you do the substitution. It's negative 6 over negative 5. Okay. So it's 6 over 5. Okay. Do you have any questions so far? All right. Okay. Then part E. I think all questions in this problem 4, they are either elimination of common factors or just do the rationalization. Okay. In part E, again, you do the substitution. It's 1 minus 1. The bottom is also 1 minus 1. So it's 0 over 0. But now what is a common factor? Okay, you have to be, okay, you can see that if the top, right, times x, what do you have? It's going to be 1 minus x, right, which is exactly negative 1 times the bottom. So that's why the bottom, if you factorize it, it is actually the top, right, times negative x. The top times negative x, you will get the bottom. Okay, and then these two parts cancel out. So it is limit 1 over negative x. So it's just negative 1. Okay. So yes, it's still elimination of common factors, but you know, it's for some elimination it's a little bit harder than other eliminations. Part F. So now it's some trigo cosine 2t over cosine t minus sine t. Okay. Again, try substitution first. right? This cosine, sine, pi over 4, they are both, right, square root of 2 over 2. So, right, the bottom is 0. Top, cosine half pi is 0. Right, so it's still 0 over 0. Okay. But here you need to use the fact that cosine 2t is what? Right, it's essentially cosine t squared minus sine t squared. Okay, that's the formula for cosine 2t over cosine t minus sine t. Okay, and for the top, it's again a squared minus b squared, right? So it's just, right, it's just cosine t minus sine t times cosine t plus sine t. Okay, over cosine t minus sine t. Right, so these two parts cancel out. You have only cosine t plus sine t. Okay, then do the substitution. It's this part is square root of 2 over 2. This part is square root of 2 over 2. So the result is square root of 2. Okay. Right. G. Okay. H approaching 0. Right. Very, very similar. Right. Subbing, you have 2 cubed minus 8 is 0. So it's 0 over 0. So again, should be something in common. Right. So here at the top, it's actually a cubed minus b cubed. Right. So the top is actually a cubed minus b cubed. Here, it's 8, so it's 2 cubed. Right? A cubed minus b cubed, it's a minus b times a squared plus ab plus b squared. Okay, so you can do that. It's a minus b, right? So this part is a, this part is b. Okay, times a squared plus ab plus b squared. Okay, over h. Right? Then this part, 2 plus h minus 2, it's h, right? H and h, they cancel out. So the result is, right, this part, 2 plus h squared, right, plus 2, 2 plus h, plus 2 squared, okay? Then you just sub 0 in, you'll get the answer, right? So 4, 4, 4, the result is 12, okay? Okay, problem H. Problem H, limit x is approaching 7 plus square root of x plus 2 minus 3 over x minus 7. Right, so again, do the substitution. 7 minus 7 is 0. Here it's 7 plus 2 square root minus 3, it's also 0. Okay, so here you have square root minus, so you can do the rationalization. You can use the square root minus times the square root plus. Okay, square root minus times square root plus. Okay, then the top, it's a minus b times a plus b. So it's just x plus 2, right, minus 3 squared. Okay, the bottom is x minus 7 times square root of x plus 2 plus 3. Okay. So the top, it's actually x minus 7, right? The bottom, x minus 7. So cancel out. It is just 1 over square root of x plus 2 plus 3, right? Then do the substitution. It's 1 over 6. Okay. So it's either rationalization or, eliminating common factors. It's either one of these two methods. Okay, last one. Right, second last one. Limit. Right, t is approaching 0 from the right hand side. And it's 1 over t minus 1 over t squared plus t. Okay. So here's a little bit different because if you do the substitution, 1 over t, right, you can see actually this limit exists, right? This limit itself is positive infinity. However, if you do, if you analyze this limit as well, this limit is also positive infinity. Okay, so you can't say positive infinity minus positive infinity is 0. Right? It doesn't make sense. Okay, never ever treat infinity as a number. Okay, infinity is just a concept. It's not a number. So don't, calculate with infinity as a number. Okay, never do that. Instead, right, we can first do this. We can write it as a fraction t times t squared plus t. So this part is t squared plus t minus t. Okay, so it's a limit. T approaching 0, and the top is t squared. The bottom is t cubed plus t squared. Right, so you can do the, right, so t squared can be canceled out. So it's 1 over t plus 1. Right, then you do the substitution, it's just 1. Okay. Right, so part J. Part J is a different, it's one of a kind. It's different because now x to the power 4 times cosine. Okay, so you try to do the substitution. Here it's 0 to the power 4. Okay, this part is 0. The limit is quite obvious. But this part, cosine 1 over x, okay, this is our headache because when x is approaching 0, first, your 1 over x, the limit, right, it doesn't exist. Okay, when x is approaching 0, your 1 over x, its limit doesn't even exist. Why? You draw the graph, it's very obvious. Because 1 over x, when x is positive, it looks like this, right? When x is negative, it looks like this. Okay, then when x is approaching 0, you can see from the positive side, it's approaching positive infinity. Right? From the negative side, it's approaching negative infinity. Okay, so this limit doesn't even exist. Okay, so that's a trouble. Okay, but is there any way for us to bypass this part? Okay, because yes, this limit itself doesn't exist, right? But if you multiply that with x to the power 4, What's the effect? Right? The effect is this first part, it's closer and closer and closer to 0, right? And this second part, its value is alternating. It's changing between -1 and 1. Okay, because no matter how 1 over x change, since you have a cosine, so cosine anything is always between -1 and 1, right? It's always like this curve between -1 and 1. So this part, although its limit doesn't exist, but we know its value is always between -1 and 1. So the product, right, it should approach 0, because this first part is more important than the second part. Okay, so I think that's the intuition. We know the result, it should be 0. But how can we do it mathematically? Right? We need to use something called the squeeze theorem. Okay, again, squeeze theorem is very easy to understand if you draw it on a graph. Okay, for example, you have a function, let's call it gx. Right? You have a second function, right? Let's call it fx, and the third function, okay, let's call it hx. Okay, and you can see first the relation between these three functions is quite clear. Right? This is the highest function. Right? This is always a function in between. Right? This is a lower function. Right? It's always smaller than the first two. So that's the first condition of a squeeze theorem. So to use the squeeze theorem, you need to find a function that is always greater or equal to fx, and you also need to find another function always smaller or equal to fx. Okay. So let's say this point is point A, right? When x is near A, okay? It doesn't have to be in the whole domain. This is always true. It doesn't have to be that. We only care about the area near A, right? The neighborhood around A. When x is near A, this relationship holds. That's enough. Okay, that's enough. Okay. The second condition is that, right, the first function's limit, right, when x is approaching A, the first function's limit is equal to the third function's limit. Okay, and it's equal to some value. For example, let's call it L. Okay, on the graph, it's quite clear. When x is approaching A, you can see this higher function, gx, its limit is this point, right? And for this lower function, its limit is also this value. Okay, so at this specific point, both the higher and lower function, they have the same limit value. Okay, then naturally the function in between, it must have the same, right? It must have the same limit value. Okay, so if this is true, right? So you always, when you do the squeeze theorem, you always check these two conditions. Okay, if the first condition is checked, the second condition is checked, then you can say by squeeze theorem. Right, this function in between's limit is also L. Okay. Okay, so to apply the squeeze theorem, always check first thing whether you can find two functions. One is always greater, one is always smaller. Okay, and then the second thing is, are these two functions sharing the same limit value at the point? Right? And if both are true, both are correct, then you can say by squeeze theorem, this function in between at this x approaching A's limit is also the same value. Okay. Okay, so for this question J, so why do we even think about using squeeze theorem? That's all because of the nature of cosine. Okay, that's because cosine, any angle, right, it's always between -1 and 1. Right? No matter what you put into a cosine, its cosine value is always between -1 and 1. Right? So this is an inequality that could easily give us the higher function and the lower function. Okay, because if you multiply, right, the first thing here, I don't care, inside it's 1 over x or x squared or whatever, this cosine 1 over x is always between -1 and 1. Right, and then you multiply cosine x with x to the power 4. So this x to the power 4, it's always a non-negative number. So you multiply this. Its range is still, okay, it's between x to the power 4 times 1, and it's greater or equal to x to the power 4 times -1. Okay. So now this is the first box you need to check for the squeeze theorem, right? You find a function that's always smaller, a function that's always bigger. Okay. The second fact you need to verify is that, all right, the functions on both sides, their limit must be the same value. Okay? And here it's quite easy to verify. Okay, the function on the left, its limit is just 0. The function on the right, its limit is also just 0. Okay. So two boxes are both checked. So these two combined. Right, so you can say by squeeze theorem, right, limit x to the power 4 times cosine 1 over x, right, its limit is also 0.